Hello everyone, and welcome back to the show. I'm your host, ichino-ani, and it's great to have you here. Today is November 10th, a wonderful Monday in 2025. And as always, we've got a super interesting, trending article from ichino-ani archive to talk about. Alright class, let's get our thinking caps on. Today's paper is all about teaching robots in a smart way. The title is a bit of a mouthful, get ready. Road to Save Policy Evaluation with Gaussian Splatting Simulation of Soft Body Interactions. That's a long one. The call is also quite the journey. It's tats://arxiv.org/abs/2511.4665 So what is this paper trying to solve? Imagine you're teaching a robot a new trick, like packing a soft, squishy teddy bear into a small box. In the real world, you have to run the test over and over again. This is really expensive, it takes a ton of time, and it's hard to set up the exact same way every time. It's a huge bottleneck for making robots smarter. You might think, let's just practice in a video game or a simulation first. That's a great idea, but there's a big problem. Most simulations aren't very realistic. The lighting might be different, or worse, the physics are all wrong. A soft teddy bear in a normal simulation might act like a hard block of wood, so the robot learns tricks in the game that just don't work in the real world. This is a famous problem called the sim-to-real gap. This paper presents a brilliant way to close that gap. The researchers created an incredibly realistic simulator that works like a digital twin of the real world. How did they do it? They used two super cool technologies. First, to make the simulation look real, they used something called Gaussian Splatting. It's like this: they take a video of the robot's work parts with a phone, and this technology turns that video into a perfect, photorealistic 3D scene. It looks so real, you'd think it was a photograph. And they even figured out a way to automatically match the colors, so the simulation looks exactly like what the robot's own cameras see. Second, to make the simulation feel real, especially for soft and wobbly things, they used a system called PhysTwin. This is so clever. We recorded a video of a person playing with an object, like swishing a plush toy or bending a rope. The computer watches this video and learns the object's physics, like its stiffness and how it deforms. So the digital teddy bear in this simulation is just as soft and floppy as the real one. By combining these two things, a world that looks real and objects that feel real, they created a simulator where a robot can practice, and what it learns actually transfers to the real world. And the best part, their test showed a super strong correlation. We're talking over 90% between your robot's success in the simulation and in real life. That's amazing. So, where can we use this kind of technology in our daily lives? Let me give you a few examples. First, think about self-driving cars. This is a big one. Before an autonomous car drives on your streets, you need to be sure it's incredibly safe, instead of just driving millions of miles in the real world, which is slow and can't cover every possibility. Companies can use this kind of hyper-realistic simulation. They can create a digital twin of a city and test the car's AI in millions of different situations, like sudden rainstorms, a ball ringing into the street, or even how a plastic bag might blow across the road. This makes testing much faster, cheaper, and way safer. Second, let's talk about robotic surgery. Surgeons are now using robots to perform very delicate operations. Practice is everything. This technology could create simulators of human organs that are incredibly lifelike. A surgeon could practice a difficult procedure on a digital twin of a patient's heart or liver that looks and reacts just like the real thing. This would let them perfect their skills in a completely safe environment, before ever touching a real patient. And for a third example, think about all the robots in warehouses and factories. They are great at moving hard boxes. But what about soft things, like packing a t-shirt into a bag without wrinkling it, or grabbing a bag of potato chips without crushing them? These are really hard tasks for robots. With this kind of simulator, companies can train their robots to handle all sorts of deformable products. The robot could practice thousands of times in the simulation to learn the perfect, gentle touch for any soft item. So this research is a huge step forward. It gives robots a safe and realistic playground to learn in, which will help us develop smarter, more capable, and safer robots for all sorts of important jobs. Isn't that just the coolest thing? Well, that's all the time we have for today. Great job listening, everyone. Class dismissed.